A lion is 60 meters behind you. You can hear it. You can feel the vibration of it through the soles of your feet. Your legs are already burning. What happens in the next 4 seconds will be decided by something you have never trained for. But your ancestors trained for every single day for 300,000 years. Most people assume modern athletes are peak human. Usain Bolt ran 100 meters in 9.58 seconds. He is the fastest human ever recorded. A lion in full sprint covers the same ground in under 5. Put them on the same track and the outcome seems obvious. But a savanna is not a track, and surviving a lion is not a race. The assumption most people carry is that ancient humans were prey. Fragile, slow, terrified hominins huddled in rock shelters while the megafauna of the Pleistocene ruled the open ground. That image comes partly from old fossil narratives and partly from the uncomfortable truth that we are, physically, not very impressive animals. No claws, no fangs worth mentioning, no armor, moderate speed on a good day. But that image is wrong, and the fossil record is very clear about this. So here's the real question. If a lion started a charge today, who would survive? A modern Olympic sprinter running alone, or one of your ancestors running barefoot across the Pleistocene savanna with nothing but a sharpened stick and the people beside them? The answer will change how you think about your own body. Start with the lion, not as a symbol of danger, as a biological system with very specific constraints. A lion is an ambush predator. It does not chase. It stalks, it waits, it calculates, and then it explodes. Its top speed is somewhere between 70 and 80 kilometers per hour. That is terrifying, but that speed has a ceiling of roughly 200 to 300 meters before the lion's internal temperature rises past a threshold it cannot sustain. Lions have no sweat glands in the way humans do. The muscles generate enormous heat. The body cannot flush it fast enough. A chase that goes long kills the lion as surely as a chase that goes wrong. This is not a secret. This is physics. Your ancestors did not know the biology, but they knew the behavior. They had watched lions their whole lives. They had watched their parents watch lions. They understood, in the way you understand, that a hot pan means pain without needing to study thermodynamics. That a running lion is a problem with a time limit. A modern sprinter does not know this. A modern sprinter lives in a world where lions are on television. Now consider what your body was actually built for. Craig Stanford, a biological anthropologist at the University of Southern California, has documented how the human body plan is a product of millions of years of locomotion pressure on the open savanna. Upright posture, a narrow pelvis that allows a long stride, an Achilles tendon that stores and releases elastic energy like a spring, and most importantly, eccrine sweat glands that flush heat, covering nearly the entire body surface. Up to 4 million of them, allowing humans to offload metabolic heat continuously during sustained effort. No other large land predator has this system. The horse has it partially. Humans have it completely. What this means is that humans were not built to sprint. Humans were built to run long and slow and hot and never stop. Paleoanthropologist Daniel Lieberman at Harvard, whose research reshaped how scientists understand barefoot running and endurance, argues that persistence, hunting may have been one of the earliest and most decisive weapons in the human arsenal. Not speed, duration, chasing prey at moderate pace across long distances in midday heat until the animal collapses from overheating. Not because humans are faster, because humans can keep going when nothing else can. A modern sprinter's body is tuned away from this. Not because they are less capable as humans, but because years of specialized training rewires the neuromuscular system for maximum power output in 10 seconds. That is a different tool entirely. Your ancestor's tool was a 6-hour body. The sprinter's tool is a 10-second body. The lion closes a 60-meter gap in about 4 seconds. So what actually happens in the first moments of a charge? At full sprint, a world-class human runner covers roughly 10 meters per second at absolute peak velocity. A lion covers 22. If the lion begins its charge at 60 meters, it reaches you in under 3 seconds. A sprinter might add a half second of reaction time advantage. A perfect start might buy a full second. Neither saves them on open ground alone. Your ancestor does not try to outrun the lion. Your ancestor was almost certainly not alone. The evidence for this comes from multiple sites. Manuel Dominguez Rodrigo and his team, working at FLK Zinj in Tanzania's Olduvai Gorge, one of the richest early human archaeological sites ever excavated, found bone assemblages showing coordinated group access to large animal carcasses as far back as 1.8 million years ago. These were not scavengers stumbling on leftovers. These were groups operating with social strategy in landscapes shared with large carnivores. A lone individual in open grassland is exactly what a lion's nervous system evolved to target. A coordinated group is something entirely different. Lions are not suicidal. When an ambush breaks in an unexpected direction, when the prey closes in instead of fleeing, when multiple large objects are suddenly upright and loud and throwing things, the lion's calculation changes. The risk of a broken leg, a torn muscle, a rock to the skull makes the ambush not worth it. Lions abandon hunts constantly. They are extremely cautious about injury because an injured lion is a lion that cannot hunt and therefore a lion that starves. Your ancestors made themselves into an injury risk every time they held their ground together. Let's reconstruct the scene properly. It is roughly 150,000 years ago. East Africa. Late morning, dry season. A group of 9 people, 6 adults, 3 older children old enough to keep pace, is crossing open scrubland toward a seasonal water hole. The grass has been grazed short. Visibility is good. 2 people in the group are watching the tree line without being asked. This is not a sign, it is habit. The lion breaks from behind a termite mound 40 meters to the left. No warning sound, just sudden movement. 3 people shout simultaneously, not in panic, in signal. The group does not scatter. 2 men step forward and left toward the threat, holding wooden shafts. They make themselves large. They yell. One of them throws a rock, not because the rock will injure the lion, but because the motion disrupts the lion's targeting. The children and 2 of the women move to the rear right in a motion that looks almost choreographed because it has been practiced. Not drilled consciously, but lived and watched and inherited. The lion pulls up 8 meters out. It has approximately 2 more seconds of full-speed chase available before its temperature forces a stop. The target has become a cluster of upright, noisy, rock-throwing organisms with no clean angle. The calculation doesn't resolve. The lion breaks left and loops away into the scrub. The group keeps walking. Heart rate's elevated. No one stops moving. Now remove the group. Place a single modern sprinter in that same field. They are faster than your ancestor over the first 2 seconds. They are also completely alone. They run in a straight line, the only rational option for a single organism trying to escape. The lion has a clean vector. The gap closes. The outcome is different. Louis Liebenberg, a mathematician and tracker who spent years running alongside sand hunters in the Kalahari, documented something in the 1980s and 1990s that most of the Western scientific community found almost impossible to believe at first: persistence hunting. Sandmen would track a large antelope on foot at moderate pace in temperatures above 40 degrees Celsius for 4 to 6 hours until the animal simply collapsed from hyperthermia and could no longer stand. The hunters did not need to be fast. The animal was faster. The hunters needed to be relentless to track accurately across difficult ground and to tolerate heat that would end the animal's ability to function. Their bodies were built for exactly this. The animal's was not. Speed is a short-term weapon. Endurance is a long-term weapon. Your ancestors had the endurance weapon, and they understood, at a level older than language, that it was enough. Here is the part that most people miss. Predators were not the primary cause of death for most ancient human populations. They were a selection pressure. They removed the slowest, the most careless, the groups with the worst social coordination. But infection killed more. Starvation killed more. Drought killed more. The loss of a single person who held critical knowledge, where the spring was, how to treat the infected wound, which plants were poisonous, could unravel a group faster than any lion. The lion is almost the easy problem. It is fast, and it is loud, and it triggers every alarm in your nervous system. The hard problems are invisible and slow. What your ancestors developed to deal with the lion, group coordination, shared attention, practiced response, is the same infrastructure that kept them alive through the invisible problems. The same social architecture that made them dangerous to a predator made them resilient to everything else. Every scar your ancestors survived became part of the body you inherited. A lion is 60 meters behind you. You can feel it through the soles of your feet. Your legs are burning, but somewhere older than fear, there is a calculation already running, counting the people beside you, reading the lion's angle, watching where its eyes are fixed, knowing how much time the heat gives you before the lion's own body betrays it. Your ancestors ran that calculation every morning for 300,000 years. The question was never who runs faster. It was always who survives smarter. And the answer, every time, was the same. Every human alive today carries the legacy of those who learned that survival wasn't about being the fastest. It was about never facing the danger alone.